Hey guys, the last time we talked about 4.4 and in there we learned the big two concepts. The very first one that we learned was about how to graph like the log functions, and I make a mistake, I make a typo in my last video of 4.4 part 1. So I told you guys about the free numbers, but let me just like shortly like talk about them right here real quick. So we have like two type equations, right? We have like exponential equation, let me put it in pink, and then the other type is like log functions. So say if you're gonna have a problem for log, say I don't know, like ln of I don't know, like x minus 1 and then plus 2 in here, and then for the exponential, say you have something like e to the x plus 1 minus 2. Okay, I'm just gonna make them up. And if you want, you can like input some number in front, like it doesn't matter, like it's not gonna change your problem too much. Oh, this is in like orange. Okay, let me make up like a 4 in here, or whatever number you want to call it. Okay, so for like logs in here, the free numbers is actually like the one inside the function. Okay, and it's a VA, it's a vertical asymptote, and since it's like VA, it always have the form of like x equals to something. And on the inside we have like x, the free number in here is -1. That means that we're gonna move it to the right by 1 unit. So technically we're gonna have x equal to 1. Okay, so my trick in here is that you always grab whatever like inside the log in here, and then you set it equal to 0. So in here we're gonna get something like x minus 1 equal to 0. After you solve for x, you're gonna get the vertical asymptote. Okay, and then for exponential functions, it's gonna be easier. The free number is actually the number outside the function, not inside. And then for exponential functions, we're gonna have horizontal asymptote, and since it's horizontal, it's gonna go with like y equals, and in here you're not gonna do anything, you're gonna like keep the number as it is, so it's gonna be like y equals to 2. Okay, so like for my personal experience, if you have like an inside number, you always have to change the side of it. So say if you're gonna have like a -1 right here, then well, you have to change it into a +1. Okay, but if you have like an outside number like here, and it's for like y, you're gonna keep the number. Okay, like you're not gonna change it. So here, let me highlight. Okay, so again, the free numbers, let me redefine really quick for you guys. For logs, it's gonna be the number like after the x inside the parentheses, and for our exponential functions, the free numbers are the one like outside the function. Okay, it doesn't like attach to x, or it's not close to x. Okay, and again for log, we're gonna have like vertical asymptote, like like a vertical straight line. While for exponential functions, we're gonna have a horizontal asymptote, which is like like a horizontal straight line. Okay, so make sure you can tell the difference between the two. And then in 4.4, we also learn about the 5 properties of log. And then make sure you have those 5 properties down somewhere in your notes, or like post it or a sticker, so then you can have it ready for the quiz 2 homework, or I don't know, like exam 1. I know like in 4.4 it has a lot to do with algebra and all the stuff like that. So if you have any question on 4.4, please ask me before you watch this video about like 1.5. okay, and let's talk about 1.5. okay, so old habit, we're gonna review some old concept first. In everyday language, people refer to a speed limit. In wrestlers weight limit, the limit of one's endurance or stretching a spring to its limit. Okay, so technically like the first bullet in here, I'm showing you guys how people use the word limit in everyday language. Okay, so then these phrases all suggest that a limit is a bound, right? Like a limit in there is like a bound to your like strength or to a certain situation, which on some occasions may not be reached, but on other occasions may be reached or exceeded. Okay, so say like like if you have a car and if you're driving, like usually on the logo, people will say like keep your speed under, I don't know, like 35 or like 40 mph on some roads. But sometimes like that's the limit that like the government tell you to follow, right, to keep everyone safe. But in some people, like I myself, it's not like a good thing to do, but then sometimes I exceed the limit, right? So sometimes on the logo, I know that's not like a good thing to do, but I hit like 60 mph, like at night time, right? It's not gonna be like in crowded street and I do that, but then I just want to tell you that limit is something like sometimes you can reach it, sometimes you cannot reach it. Okay, like in the logo, some people would write, I don't know, like 25 mph, you know, and then some people will stick with the rule and then keep the speed being just 40. I don't know if like that's the speed limit for that row. And some other people, you know, like some crazy people, they might exceed the limit by hitting like, I don't know, like 50 mph. Okay, so that's the concept, that's the idea about limit. Okay, so let me highlight the word limit in here. This is just like so that you get like a flavor of what limit is, okay, in like real life problems first. And now let's talk about like mathematically. For example, my height is like 5 feet. I'm like pretty short, you know, like standard Asian height. Well, not even like standard, but you know, ever since my 5th grade or like 12 years old, and I couldn't grow any further, so my height limit is just 5 feet, right? Because I couldn't grow any further. So from me being like 12 years old until like now being like 25 years old, it's been like 13 years, right? My high limit is just like 5 feet, okay? I couldn't exceed it, okay? But other cases, like my friend Jenny, who used to be shorter than me in my 5th grade, in our 5th grade, she's only like 3 feet 10 or something like that, you know, like around 4 feet. But now she's like way taller than me, right? Like she's like 5'6" right now. But then, you know, like everyone stopped growing like once a while, right? And then she hit 19 and then she stopped growing. So her high limit in here would be 5'6", while my high limit in here is 5, right? So the high limit can be different from, you know, like people to people. It depends on like how your body works. So mathematically, let me put it down in like functions in there. So I will have, this is me, like when I was 12 years old, I was 5 feet, right? And then when Jenny, okay, so let me just know, F is me, G is Jenny, okay? So this is my column, like the very column on the very left hand side, that's my high column, right? And then the column, like the 3 lines on the right side, that's Jenny's height, okay? So when we were 12 years old, I was 5 feet, and then Jenny was like 3'10". But then when we was 19, I was still like 5 feet, right? I couldn't grow any further. And then Jenny, she was like, you know, like 5'6", and then like back to current, like for now, like present, I am still 5 feet. I couldn't grow anymore, and then she cannot grow anymore ever since her 19, right? So her limit ever since, like from 19 to 25 years old, is still 5'6", okay? So in general, we would use a symbol for limit, okay? So f of x is the function that we have, and then x to like some point, to some value, is like the certain point that you want to consider the limit, okay? And then L in here is the value of your limit. So this is the value of the limit if you want to like, you know, like write down. This is the point when you want to like stop the time and consider the limit. And this is the function. F is for like function in general. Okay? And now let's get to more examples so I can demonstrate to you guys what I have like talking about earlier. So the very first page is not like a big fancy things in here. I just want to show you guys like 3 examples before we jump into like, you know, the very first objective. So let's talk about the limit of a function, right? Like we have 3 pictures in here. They look almost the same to each other. This one, it has the hole in there, okay? This one, it also has the hole, but then this hole kept like being like removed or like pushed down to produce like a point there. And then this one, like there's no hole in there, right? Like I make it bold, like I make the point bold, just to show you guys that there's no hole, just like unlike like the first 2 pictures, okay? And then we pretty much have the same function for all the pictures. And let me put like ping for the other one. Okay. And in fact, if you notice, like if you kind of like simplify the very first equation in here, I'm gonna get something like, you know, like on the top part, if you use the x method in there, and if you want to kind of like write out in the ABC correct form, you're gonna have something like x squared plus 0x minus 1, right? Because we don't have the b term, we don't have the middle term. So in here we're gonna have the x method, and then the top part is gonna be -1, while the bottom part is going to be 0, right? And again, you have to find two numbers that multiply, that times to -1, but then at the same time add to 0, okay? And then they are -1 and 1, right? So then this function in here, we can rewrite them as x minus 1 because we have a -1, and also x plus 1 because we have a +1, okay? That's for the top part, and as for the bottom part, we're gonna rewrite the denominator as x minus 1, and in here we can cancel the group of x minus 1, right? And then we left with x plus 1, okay? And if you notice, this is what we have for the last case, okay? So like, okay, let me put it in orange. Like this function, and this function, they are pretty much the same thing, but as you can see in there, like the first two function, this one and this one in here, we have a whole because we have like a fraction, right? Because we have like the denominator in here, and in the first two cases, your x cannot be 1, right? Because if you were to have a 1 in the denominator, that would be like 1 minus 1 equal to 0, and then we cannot divide anything by 0, right? That's like undefined. That's why whenever you have like a fraction, most certainly you're gonna have like wholes, okay? And then for the last picture, for the last case, we simplify, we cut it down, the expression already, we simplify the function already. That's why we only have just, you know, like a polynomial with no denominator, okay? So then that's why the last function, there's no whole because you actually like chop out the bad part, the part that make like 0 appear on the bottom, okay? And then for the middle picture, if you want to ask me like what's the difference between the first and the second picture, well, I'm gonna tell you. For the first picture, there's no like way to make up for the whole, right? Like we have the whole and then we just leave it as the whole. But then I want to be more creative. That's why in the second picture, I repeat whatever I had for the first picture, but then I try to make up for the whole by like putting like a y value at the whole as for like x value, okay? So in here, the whole in here, it is like x equal to 1, right? Like that's the bad point for, you know, like the very first and also the second picture. But then for the first picture, I have no y value in place of x equal to 1, but then for the second picture, I have y equals to 1 in place of x equal to 1 there, okay? So now let's talk about the questions that I have below here. So let's talk about the first picture. What is the value of f of x at x equal to 1? So, you know, like what is f of 1, right, in math terms? Well, f of 1, right, like at 1 right here, we have a whole, right? That means that we have like no y value at all. So I'm gonna say that f of 1 is undefined. Let me put it back in red, you know, red code to catch your attention. So f of 1 in here is undefined, or I'm gonna put the word like doesn't exist. D and E. Okay. For the second question, we're gonna have like the same thing pretty much, but as you can see, I changed the name of them because, you know, like just so you guys can see that there's like 3 functions in here, right? There are 3 graphs in here and there are 3 pictures in here, so they deserve like 3 functions, 3 names, okay? The first one we call it F, the second one we call it G, and the last one we call it H, okay? So then for the second question, what is G of 1, right? So if I change the color to blue, okay, so at 1 we're gonna have this like dash line here at x equal to 1, right? And then you have to ask yourself, in the dash line here, is there any point that you see like a valid point, not a whole? Well, this is the whole and this is a valid point, right? So then we're gonna say that G of 1 equals to 1, and we're talking about this point here. Please don't tell me that G of 1 equals to 2, because at 2, like at y equals to 2 in there, we have a whole, right? A whole is not a valid number, okay? So if you have a whole in there, it means that you, like this, you make the point disappear at that point already, okay? So let me like clear the things out the way so you can see like clearly. At the value of x equal to 1, there are 2 points, one valid point and the other one is invalid point, okay? So make sure you always go for the valid point. Okay, and for the last case, we have the same questions, but then in this case, at x equal to 1, now we have a point, right? Like, let me put it in, I don't know, like green. Now we have a point, just like 1 point, right? We have no whole, and it's a valid point, right? So let me put like valid point. there. So then h of 1 in here, it equals to 2 because we actually have a point at 1 with y value equals to 2. Okay? And if you want to make it more clear, let me just, you know, like take these out, and then let me just put, this is a valid point, and this in here is invalid point. And again, why is it valid? It's valid because it's filled, and it's invalid because it's not filled. Okay? And then for the next question, for the first picture, what is the limit of f of x when x is near 1? Alright, now we're talking about limit, right? So near 1, what does it mean by near? Near here, it means around, right? Like from the left part and from the right side of 1. So say if I have like x equal to 1, which is right here, the dashed line again. Let me take out some stuff in here. Okay, let me draw like a dashed line at 1 in here, so you guys have like know what I'm talking about. Okay, so this is like the dashed line of x equal to 1, right? So then now you're gonna look at this have like point from the right hand side and also from the left hand side, right? So as you can see, the left hand side is coming to 2, and also on the right hand side is coming to 2, right? So the limit of f of x when x approaching to 1 or like comes near 1 is 2. Okay, and how can we put it down simple in like math? I'm gonna write limit x is near 1, f of x equals to 2. Okay, and with the same idea, let me put it in blue for the second picture, and let me take out some stuff in here just so you guys can see it like better. Okay, so the second picture, again, we're looking at like x equal to 1, but then we have to look from the left and the right hand side of it, right? Let me take out these words here because I don't feel like you guys need it anymore. Okay, so we're focusing on these 2 points again because like on the dashed line of x equal to 1, we have 2 points, right? One valid and the other one invalid again. So which of the point here has the right hand side and the left hand side? Hopefully you guys agree with me that this one has the right hand side and also has the left hand side, okay? Like the second one in there, this is just a point, right? It has no connection whatsoever with your function on either the left hand side or the right hand side. Only the first point, even though it's invalid, it is kind of like connected to the left hand side and also the right hand side, right? Like the second point, it's just like a point. It doesn't have like any arms on 2 sides. While the first point here, even though it's not even like a point, it's not like a perfect point, it's invalid, it's not filled, but then it has like the left arm and it's also have the right arm, okay? And if you ask me like what I mean by left arm and right arm, let me just trace it out right here. Like this to me is the right arm of the invalid point, and this to me is the left arm of the invalid point, okay? And again, like toward the point that we're looking at, they're coming at the same value, right? And it's on 2, okay? So then I'm gonna do the same thing, right? I'm gonna do limit, when is it? When x approaching 1, right? Of what function? Of g, of the function g, is also equals to 2. Okay? And now, last part, the last picture in here, let me put it in green. Okay, we have just 1 point to consider, right? Like it's less complicated than the second picture. And now, how do we do it? Well, we're gonna take a look at the left arm and also at the right arm, right? So they all coming at 2, right? So again, we're gonna write limit x approaching to 1 of h of x equals to 2. Okay? So just to confirm about the very first concept about like the idea of limit being used in like real life application, I want to tell you guys that, well, in the first picture in here, even though you don't have the point, like you don't have the valid value at 1, right? But you still have the limit of it, okay? In the second picture, you have like the value at 1, but then unfortunately it's different compared to like the limit of it, okay? And then the last picture, you're lucky enough, the value that you have at 1 is the same thing as the limit you have at 1, okay? And then let me show you like a way to compute it, the limit without the pictures, right? Because like chances are you're not gonna be able to always see the graphs of everything if I ask you to compute the limit. So how should we do it, right? Let me take out some things again in here. Okay, so earlier I told you the functions that we had earlier is like, like x minus 1, and then x plus 1, and then I rewrite the bottom, which is x minus 1. I cancel these, and I got x plus 1, right? Like, this is the simplified version of f, right? Like the function f. Okay, so talk about the limit in here. I mean, first of all, if you just write like f as, like x squared minus 1, and then x minus 1 in here, and you have like, whoops, x approaching to 1 in here. If you plug 1 into like the x's in here, then on the top part you're gonna get like 1 squared minus 1, which is 0. On the bottom part you're gonna also get 1 minus 1, which is 0, right? And this is undefined, right? Because we cannot divide anything by 0, including 0 itself. So this is like doesn't work at all, right? So instead of using like this expression in here, well, we're gonna like simplify it with another expression, okay? So let me take these out before you guys like get to it. So then now we're gonna do limit x approaching to 1 again, but then instead of using the original function, we're gonna use the simplified version instead. So we're gonna have x plus 1 in there, and now if you plug in 1 into the x, you're gonna have 1 plus 1, which is 2, right? And check it out, this is the same thing as we had earlier while we look at the graph, right? So this is like one way to find out the limit just by, like algebra, okay? So you have the function. If you plug in the value of x, that doesn't work, then it means that you have to simplify your function, okay? And after that, you plug in the value of x again, and then it works, so then you call it an answer, okay? And same thing for the second image in here. Is the same thing goes for like the g, the second function in here. Well, at x equal to 1, we do have a thing, right? Like we do have a value, but it's not about like the limit, okay? The limit is about the left hand side and the right hand side, okay? It's not like about what you have exactly in there, okay? So you can have like a different value, but then like you can also have like a different limit, okay? Like just because you have like a valid value at the point of x, it doesn't mean it's also equal to your limit, okay? So then same thing in here. If you're gonna like simplify it, you're gonna have a 2, and then lastly this one in here, because it's already simplified, then you just have to plug in 1, right? So in here we're gonna have something like limit of x approaching to 1, but of x minus 1, because it's the function that we had originally. And then in there you plug in 1 plus 1, and you're gonna have 2, okay? And this is like the same answer as we have before, okay? And then I left the spot for the domain, but then I forgot to cover it, so let me get back to it really quick. Here, I think this space should do. Okay, so domain, right? I told you guys that the domain is whatever like your x value cover, right? So for the first picture right here, we have everything on this slide except for the value of x equal to 1, right? So that means that you have all real number, R for all real numbers, okay? Except for the value of 1, okay? The backslash in here is for except for, okay? And then the brackets in here is like the symbol for set. So if you want, you can write it this way, or if you don't want to write it this way, if you get used to like the symbol of like interval notation, just like how you do it in the homework, you can write something like like from negative infinity to 1, but then you drop it, you don't 1 to 1, and then you connect it with from 1 to infinity, okay? Like either symbol will do, okay? Personally, I like the set notation because it's shorter, but again, you have the two options, either that one or the very first option that I told you guys, like R for all real number and except for 1, okay? So either or, okay? You don't have to do both, especially when it comes to like like quiz or test. You don't have to do both at all. Okay, so then for the second picture in here, well, we pretty much have the same thing, right? Like we have everything except for the value of 1, but wait, at 1 is defined, right? Like this one in here, it can't replace for that whole like vertically, right? So then we're not gonna have like anything undefined here, okay? So the only bad number that we're supposed to have for this function in here is when x equal to 1, but fortunately, as you can see in here, when x equal to 1, y or like g equals to 1, right? So at x equal to 1, the function is still defined, right? So that means we're gonna have like all real numbers for the domain, okay? Excuse me. And then for the last part in here, like this one is a perfect line, right? Like it doesn't have any disconnection, discontinuity, or anything else. It doesn't even have a hole at all, right? It's just a smooth line, right? So that means that it contains everything. It contains like all the x number. So then again, the domain in here will be all real numbers, or just, you know, like from negative infinity to positive infinity, if you want to use the interval notation. Okay? So now, let's talk about the very first objective of the day. Well, not even yet, right? So, alright, so let's talk about all the properties and up limits in here. So there's a lot of rules just like before. Make sure you kind of like print this table out or write that somewhere before the test come and quiz come. This is like very useful, okay? So, alright, so this one in here is like the definition, like the symbol of writing like limit that we've been using, right, from before. And again, f in here is a function, c in here is the value that your x is approaching to, and l in here is the value of your limit, okay? And this one is, it can come from either side, meaning like from the left hand side of your point and also from the right hand side of your point, okay? And then properties of limit, let b and c be real numbers and let n be a positive integers. We're gonna have like 4 properties in here. The first one in here, limit of f of x as x approaches c, what is it equal to? Well, in here we just simply plug in c for x, right? Then we're gonna get like f of c. That's just pretty much like direct substitution, right? Like that's how we do it for, like, you know, like the last case when you have like substitution in here, right? So you just like substitute a number that x approaching to the function, and then you got out the limit, okay? And then for number 2 in here, we have limit of p of x. P for polynomial, that's why you start with p, so we call it like p of x. And again, this one is a pure plug-in, right? Like you just plug the value of like c in for x, and then you end up with p of c, okay? So 1 and 2, they pretty much the same thing, okay? And then number 3, if you notice, we don't have like any like function of x for number 3, right? It's just like a number, right? So that means like the value of c in here, it doesn't affect b at all because it doesn't like depend on x. So that's why you're just gonna end up having like the same number as b, okay? For example, if I give you something like, I don't know, like limit of x approaching to 1 but up 2, then the answer in here, it must be 2 because I just rewrite a number in here, okay? And if you must understand this one, let me draw like a picture of this. Okay, some of you guys might remember this one. When we have like a function f of x equals to 2, you can simply understand it as like y equals to 2, right? And we learned that the line y equals to 2 is the horizontal line, right? Whereas the slope is equal to 0. And then here at 2, I'm gonna like draw a horizontal line like this, okay? So then at x approaching to 1, meaning like right here, we have like this point, right, on the line of y equals to 2, right? And if you come from the left hand side of the point, like if you come from the left hand side of the point, and also if you come from the right hand side of the point, they get into the same limit, right? And its limit right here is 2, okay? That's why the number stayed the same for the limit and also for the function, because the number in here doesn't depend on x at all, okay? So say if I change the number to, I don't know, 5, so I'm gonna have like limit at up to as x equals to 5, right? So I'm gonna like go to 1, 2, 3, 4, 5, and now we gonna have the point right here, right? And if you look from the left hand side, like the whole thing, and then the right hand side of 5, it's also coming at 2, right? That's why it doesn't matter what your x is. Well, your limits for like a fixed number, for a constant number, is always itself, okay? And for next one, for this one, well, you're gonna have an x in here, right? So again, it's just like simply like, you know, you plug in c for x, and then you end up having a c, okay? And then again, this one, you have an x, that means you have to plug in something. you plug in C, and again you have the answer. Okay, and then the last property, limit of the n root of x, right? Well, it has the x, so again you're just gonna plug them in. You end up having the answer. But watch out for the roots because they have like two kind of roots, right? It has the even root and it has the odd root, right? For even root, we cannot have C negative, okay? So say if you're gonna have like a square root, square is 2, right? So 2 is even. Square in here is the even root, right? Just imagine if your C is not a positive number, then you're gonna end up having something like square root of -2, right? And then if you guys heard of imaginary numbers, that's like the thing that learn in, I don't know, like algebra or like even in trig. But then I haven't taught you guys about imaginary numbers yet. So if you don't know it, I'm not going to expect you to know it, okay? So it's okay to not know about like imaginary numbers, okay? And you don't have to use imaginary numbers in this class, at least not for this point, okay? So just make sure that when any is like even, when you have like a square root, a fourth root, a sixth root, whatever inside your root, it must be positive, okay? Because if you have like a negative number in there, it's not gonna work, right? Like if you put in square root of -2 or like square root of like -10 into your calculator, it's gonna show you an error, right? Like it doesn't work at all, okay? Now let me cut these out first so we have more space. All right, so for example, if I give you a function, this, and if I give you like x approaching to -2, right? Then what you're gonna do, you're gonna plug in -2 for each time you see an x, right? So here we go, -2 and another -2. You plug everything into your calculator, you get the answer. And again, this method in here is just substitution, okay? So all these properties in here, they're just telling you that technically whenever you have like a function that depends on x, you plug in C, okay? Like whatever the point, the limit that x approaching to, you plug them in for x, okay? And now let's talk about the operations with limit. Okay, so just imagine you have like a scalar, a number that multiplies to a function, okay? And like originally, you know that your limit of the function is L. Then technically, all you need to do is just take that number out and then multiply to L, like the value, and that's it, okay? To demonstrate what it is, here, let me give you guys an example. So limit at x approaching to 1 of, I don't know, like 2x, okay? Well, we all know the answer is just, you know, like 2, right? Because we just plug in 1, and 2 times 1 is 2, right? But I don't know if you want to make it fancy, because you notice that, well, x in here is a function, and 2 in here is a scalar, or like a constant. This one is a scalar, okay? If you want to be fancy in math, right, you call it a scalar instead of, you know, like a number. Then, well, you can do something like pull out a 2. So you're going to have this equal to, you know, like 2 and then times limit of x approaching to 1 again. But then your function now, it's just x, right? Because you already pulled out a 2. Because the 2 has nothing to do with the x. It doesn't have any variable involved with the x. 2 is just a number. It's free from x. That's why you can pull it out, right? And on the inside here, if you do this thing out, you plug in 1 for x, right? So this thing in a circle is just 1, right? So then you're going to have like 2 times 1, which is 2. And again, the answers, they matching it with each other, right? So either way would work, right? But then, you know, like, I agree with you that the first one would be like way faster, right? So you don't have to like bring things out, and then you don't have to like do double step again. But then in some scenarios, you might have to bring out a scalar, just, you know, to make the problem easier. Okay, so that's like a quick example right there. Second example, this one you're going to use it a lot. Technically, it tells you that, well, whatever functions you have inside the limit, operations of them, either it could be like sum or difference in there. You can do the same thing for the limit, okay? And then the product, same thing. If you have like two functions multiply with each other inside the limit, then like the result in there will be the two values multiplied with each other. Quotient, same thing, but just watch out for the denominator, okay? Make sure that there's no zero denominator, okay? Power, this one we just plug it in, right? So limit of, you know, like f when x approaching to c, it is L right here. So then technically in replace for that, we're just gonna plug in L, and then since 5 it has a power of n, then the answer in here will just be n to the power, L to the power of n, okay? Same thing for 6 as radical. The only difference in here is the square root or the n root in there. So you're going to replace the limit with L, and then you keep the n root, and then you're going to get like n root of L out, okay? And just like number 4 from the last problem, watch out for the even root, okay? So say if you're going to have like a 4th root or like a 6th root if you want, if you put like negative number underneath the 4th root or like any even root you want to, this is not going to work, okay? So make sure anything that's underneath of your even root, they have to be all positive, okay? Always, okay? And now, finally, let's talk about the very first objective of today. Okay, so let's start with the replacement theorem, okay? So let's C be a real number and let f of x equal to g of x for all x that's not equal to c. Okay, I'm gonna tell you what it means in a second by like having x not equal to c. If the limit of g exists and x approaching to c, then the limit of f also exists, and limit of f of g equals to limit of g of x. Okay, so what does it mean? Okay, so if you remember in the very first page after the review page, in page 2, we have like 3 examples, right? Like the f in there, I call it, I don't know, like x squared minus 1, and then x plus 1, right? And then we did the math, we simplified this, and then we got the outer function as x plus 1, and this is my bad, this is supposed to be a minus, so it's canceled out to get x plus 1, right? So I told you guys these two are pretty much like the same compared to each other. It's just like g is the simplified version of f, right? F is a more complicated version with more restriction on the domain, where x cannot be equal to 1, but then for g, x can be anything. Even if you plug 1 for g, like it's not going to change anything, right? It doesn't matter because g is defined everywhere, right? So in here you can say that f is pretty much equal to g, just like the requirement in here, except for 1, right? Like when x equals to 1, these two functions cannot be equal to each other anymore, because in here you're going to have like 1 plus 1, which is 2. In here you're going to have undefined, which is p and e, right? And again, you cannot have 1 in the first function, because when you plug in 1, you're going to have like 0 divided by 0, which is undefined. Okay, so let me just write e and e. Okay, but if you double check up it, I'm pretty sure I used the function h in the last example, so let me just stick with the name h in there. If you double check this on the page 2, you will see that the limit of f as x approaching to 1 is also equal to the limit of h when x approaching to 1. And the answers in here, they both are equal to 2. Okay, so this is the answer. Okay, so this is all the theorem talks about. Okay, it shows you that like once you simplify a function, it's okay to plug it in and still consider the new function, like the limit for the new function is the same as the value for the limit of the old function. Okay, so for example, go back to page 2, look back at part A and C, where you have like the function of f and the function of h. Okay, and then the only difference here is the I can't even see my own writing. Okay, the only difference here is the whole at x equal to 1. By the way, this technique is called dividing out, right? What does it mean by dividing out? It means that you're going to use the x method, or you're going to use like any factor method that you learn, and then you're going to simplify the expression now, and then you divide it, you cancel it. That's how you end up with like a shorter, cleaner function, okay? And then for my personal tip, recall all techniques of factoring, such as, like X method, diamond method, AC method, and all the good all the good formulas that you learned before. So I'm not gonna talk about like all the names in here, but technically the first one, this one right here, this one is like the square of sum, and then the square of difference. This one is the difference of the squares. This one is the cube of sum and the cube of difference, and this one is a difference of the cubes and the sum of the cubes. Okay, but I'm not gonna ask you guys to remember the names. If you guys can remember the formula, that's great. If you guys can't, make sure you have them down, okay, because these are really useful. Okay, So let's talk about the first example that we have in here. For my part, so our job is to find the limit, right? So the very first thing I'm gonna do in here is plug in -1 into everywhere I have x, right? And if you do that, you're gonna get like 2 times -1 squared, which is, you know, like 2. And then let me just take out these marks because I cannot see the problem. And then minus 1, so I have like a +1 in here, and then -3, and on the bottom I'm gonna have -1 + 1, right? And I don't need to calculate the top part because like right off the bat I can see that the bottom part gives me a 0, right? Which is a bad expression. Okay, like if you ever have a 0 on the bottom, don't continue to do your work because that doesn't go anywhere, right? We cannot divide anything by 0 at all. Okay, so this is not a good way to go for. Okay, so we know that we have to use dividing out method. Wait, I want to highlight it. Dividing out method, or if you want to call it like factoring method, and cancel it out, right? So again, you have like the x method in here, and then number -3 is going to be the top number, and then -1 is going to be the bottom number. But wait, we have 3 numbers, right? Wait, this is -1. Okay, let me take out the circles in here. Okay, but like I said, we have 3 numbers, right? We have -3, we have -1, and then there's a 2 right there, right? We haven't done anything with the 2. We took care of the -3, we took care of the -1, but we didn't do anything with the 2, and that's unfair, right? So how can we fix that? Well, we're gonna take out this -3 in there, and instead of writing just -3 on the top, we can multiply the first and the last number. So we have 2 times -3, and we end up with -6, and this is the top number that we're using. Okay, and if you wonder the name for it, if you want to like look it up, this is called the AC method. Okay, this is very useful. It tells you that you're gonna use all the numbers you have in the quadratic equation. Okay, so then again, the number in here, let me write a better 6 for you guys. It's -6. It's not -3. Okay, so don't put like a -3 in there. Okay. And again, you have to give me like 2 numbers that multiply to -6, but then somehow add together to give you 1, right? So out of my head, I have like 2 and 3, right? Because like they multiply to 6, but then they somehow like add or minus to 1, right? But the thing in here is like, which one is negative, right? So you have 2 options. If you do 2 minus 3, you're gonna get what? -1, right? So you know that you're right. But if you didn't see this right away, and if you put like a negative in front of the 2, you're gonna get like 2 minus 1, which is a positive 1, right? And we're having a -1 in here. That's why you have to change the pair. Okay? So that's like my way to know it. Okay? And then now let's continue with the problem. So I'm gonna rewrite a limit in here because this is important. And make sure you guys do the same thing in the test. Make sure you don't write just the expression without a limit in front. Okay, I'm gonna take out like 1 point, at least 1 point, if you forget the limit. Okay, so then on the top part, we're gonna get a 2 and a -3 with the x's. So it goes like x plus 2 and then x minus 3. Okay, and then on the bottom, I'm gonna get like x plus 1 in here. Now you're gonna ask me, there's nothing to cancel because we have like a 2 and a -3 on top, right? And then we also have just, you know, like 1 on the bottom. Well, I did something wrong, and hopefully you guys can tell which one is wrong. I mean, if you guys want to double check, right? Like if you multiply these 2 first terms together, you're gonna have like x squared, right? And then you're gonna ask me, wait, this is like weird, right? Because if you multiply it back, you're supposed to get 2x squared, not just x squared. So this is actually wrong. Let me take it out before like anyone get like it in their head. Okay? So here, let me write out in here in, you know, like in different color to get your attention. So we had the very first step right. It's going to be x plus 2 and x minus 3. There's nothing wrong with it. But since we have the front number, this is what I call by front number. 2 in here is the front number. Okay, like whatever number is in front of x squared is a front number. If we have a front number for AC method, we have to divide each of the new numbers that we got by that front number. Okay, so 2 divided by 2, we're going to get x plus 1 in here. Okay, but then since 2 cannot make it to 3, like 3 cannot be divided fully by 2, right? Because it's not in the times table, right? So what I'm going to do is that I swing the 2 in front of the x, and I'm going to get something like 2x minus 3. Okay? So this is more doable now. Like if you multiply the first two terms together, you're gonna get 2x squared, which is like matches with whatever we had in the problem, right? So I'm gonna copy that result and write down here. So I'm gonna get x plus 1 and then 2x minus 3. Okay, so now it makes more sense. Why? Because at least we can cancel the one that makes the function look bad, right? And now it leaves us with just limit of x approaching to -1, but of the new function, a very shorter and cleaner version, 2x minus 3. Okay, and now you can just plug in the value of -1 because we simplified it already. So if you put it into the calculator, you're gonna get 2 times -1, which is -2, minus 3, that is -5. This is the final answer. Okay, so like I said, this is a very common mistake. Okay, so first of all, make sure you don't put like a -3 on top, and second of all, make sure you take care of like the front number like properly. Okay, if you don't do it like in the right way, chances are you're gonna mess it up with the X method, and then your result would not like look right. Okay, so watch out for them, because I'm pretty sure you're gonna have to use this one in quiz 2 and also in exam 1. Okay, so now let's talk about the graph that I like give you guys in here. Like I'm not gonna ask you guys to draw all the graphs in the test because it's not like, you know, that's not like super about like business, right? But I just put it here so that it makes more sense with like the work that we do in here. Okay, so then we have the point, right, at x approaching to -1. So here, let me put it in blue. So let's draw like a dash line at x equal to -1. In this dash line, we have the point, this point right here, right? Again, it's not a valid point because it's like it's not filled. But at this point here, if you notice, the value of it is at -5, right? And check it out, that's what we had. So we know that it's correct. We know that we did the right thing. We know that, you know, like it's good. Okay, so for your example, just a heads up, you guys should have something equals to -5/4. Okay, so this is your answer. Okay, if you have any question with this one, let me know, because I purposely make this problem hard just so you guys like a flavor of conjugate. Okay, before I throw this in the test and you guys gonna freak it out, like, you know, in the test with a time limit and everything. Okay, so let me put a green star before I move on. And now, number 2, objective 2, one-sided limits. One way in which a limit can fail to exist is when a function approaches a different value from the left of c, like the point that you're looking at. Like if you remember, there's always a part that has like, you know, x approaching to c underneath the word limit, right? So this is the c that I'm talking about. Okay, so from the left hand side of c, then it approaches from the right hand side of c. This type of behavior can be described more concisely with the concept of one-sided limit. Okay, so then we always have two sides of thing, right? So we have like the left hand side and the right hand side. The left hand side is gonna be minus, and then the right side, I'm gonna call it plus. I mean, just to be fair, right? Like if you look at the XY axis in there, the left hand side in here is always toward like the negative numbers, right? And then the right hand side in here is always toward the positive numbers, right? That's where the symbol of like plus and minus come from. Okay, but if you like don't get that idea, don't worry too much. Okay, I'm not gonna test you guys that in the quiz or in the test. So just remember one thing, if you have to, is that like if you see like a C minus and the minus has to be like, you know, like floated on top, just like the power, then it means that you have to look at C from the left. Okay, so this is the left. And if you have like a plus in there, C plus, and then again the C is like floating on the power place, this is for the right hand side of C. Okay, and then existence of a limit, like a definition, if f is a function and C and L are real numbers, then f of x, then limit of f of x as x approaches to C equals to L if and only if both the left and the right limits are equal to each other, and they have to be equal to L, the value. Okay, so if you remember what we did on page 2, like on the left and on the right side of every scenario of the 3 pictures in there, they all coming at the same value, right? Like they're coming together as the same place. But in here, you're not gonna see it anymore. Okay, so for my part, let's talk about the very first example in here. So I have to find the limit with a given c, right? And in here my c is 3, right? So first of all, let me just set up the equation. So limit of x approaching to c are like 3 in here, of f of x equals to what? Well, on the left hand side, minus 3 minus, and remember the minus has to be like on top, okay? You cannot write a minus on the middle, okay? So don't write like, you know, like 3 minus like this. This is no. Don't write 3 minus like dash. This is also a big no. And don't write it in front unless I give you a negative 3, okay? So these are like the common mistakes that I always see people making. So make sure you don't do that, okay? The minus, it has to be on the top right, okay? The minus and the plus in here. Okay, let me just put like a note in here. The minus and the plus, they have to be on the top right of whatever C number that you have, okay? Cannot be in any of the three kind of like mistaken form that I have in here, okay? So let's continue to talk about my problem in here. So talk about a value on the left hand side of 3, right? So on the left hand side of 3, if you look at the x-axis, this is 3, right? On the left hand side of it, we're gonna have something smaller than 3, right? So in here we're gonna get something like, I don't know, like 2, 1, 0, whatever that is less than 3, right? And on the right hand side of 3, we're gonna get something bigger than 3, right? For example, you're gonna have something like 4, 5, 6, and so on, right? So this is for the left, and this is for the right, okay? So left hand side, less than, we have this function, right? So then this equals to limit of x minus 2 as x approaching to 3 from the left. And let me take these out. Okay. And now your job is to plug in the value for x, right? So it doesn't matter like which side it is. Whenever you have a number there, just plug it in, okay? It just tells you that this is like the limit from the left. So in here again, if you plug in 3 for x, you're gonna get 3 minus 1, which is 2, right? And just a heads up, this is what you have for the left hand side. If you want to make it like clear and obvious to you guys, don't be shy to put the word left in there. I did it to make sure that I know like which one is which, okay? And then pretty much the same thing you're gonna do from the right hand side of 3, but then this time you're gonna have to do 3 plus, okay? So again, make sure you don't do like 3 plus like this. Make sure you don't do like 3 and a subscript, like underscript plus. This is weird. And make sure you don't do like positive 3 with a plus in front. This is also weird, okay? Like people are really creative sometimes, okay? So make sure you don't go for any of these, okay? And let me take these out before any of those get into your head. These are like bad habits of some people. Okay, so again, I have like f function, right? And then I have to pick the right functions that I use. And if we're talking about like the right hand side of 3, well, we're gonna have the outer function. Here, let me highlight. The right hand side, it stands for like whatever value that is greater than 3, right? And hence we have this function in here. We're gonna use the second function, not the first function anymore. Okay, so then for the right hand side, we're gonna have negative 2x plus 5, right? And again, since you have the number in here, just plug it in, and you're gonna get negative 2 times 3, which is negative 6, plus 5, that is negative 1. And this in here is for the right hand side, if you want to make it again like known to ourselves. Okay, so on the left we have 2, on the right we have negative 1. They are not the same, right? So then again, in here we're gonna say that limit of f of x as x approaching to 3, it does not exist. Why? Because limit of f of x coming from the left of 3 does not equal to the limit of f of x coming from the right of 3. Okay, so this is the whole sentence of conclusion that I'm expecting to see on the quiz and on the test. Okay, so make sure you guys show the work in here. Wait, so sorry for this. This is 1.5. Okay, so here again, this is the work that I want you guys to show. Let me highlight it instead. these are the work that I'm expecting to see, and this one is the conclusion that I want to see. Okay, so there are two parts to it: the work and the conclusion. Okay, and again, as for the graph in here, it's just like you know, like just to compare the answer, right? So let me take all of these out, and then I'll show you guys how that match up with what we had in the graphs. Okay. Okay. So at x equals to 3, here, let me just put like a dash line of x equals to 3 so you guys know that we talking about like x equals to 3, right? We have 2 points, right? Like one valid point and the other one invalid. For the valid point, we only have the left hand side, right? Because this is like the left arm of it. And then for the invalid point, we only have the right hand side, right? And then this is like the right arm for it. Here, let me clear this thing out. Alright, so know that on the left hand side, it coming at 1, right? Like in here, if you project it to the y-axis, this is the valid 1. Okay, just like before we had. And then if you look at the right, no, this is, yeah, at 1. And then if you look at the right hand side, we're gonna have -1 if you project it sideways. Okay, so then on the left we have 1, on the right we have -1. These two values, they don't match up with each other. That's why the limit doesn't exist in here. Okay, and I think earlier I make a mistake. I think earlier I put a 2. I'm not sure why, but I think 3 minus 2, it should give us a 1, right? So forgive me if I did something weird in like the last minute, but yeah, the left limit, it should be 1. Okay, and if you want me to rewrite it, here, let me just do it really quick before we move on to the next page. X minus 2, and again, this is like x coming at 3 from the left, x coming at 3 from the left, and again I'm gonna plug in 3 minus 1, I mean 3 minus 2, there we go, and then I have 1. Okay, I think I'm mistaken, like 3 minus 1 for some weird reason, that's why I ended up with like 2 earlier, but yeah, sorry for that. Okay, so again, this picture in here just tells you that we're gonna have 1 from the left, we're gonna have -1 on the right, and hence the function in here is not connected, right? Like if you can see it here, let me take these out again. The functions in here, they are like 2 parts apart from each other, right? Like they're not a smooth function. A smooth function, it would be like this, or it can be like this, right? Or it can be like wavy, but as lead is smooth, right? This is not a smooth function because it had like 2 pieces. Okay, so it's not continuous. It's not like, it doesn't have the limit at x equals to 3. Okay, and then this is for your part. Okay, and notice that just by looking at the graph, your function is connected to each other at the same value, right? So you should have the same answer from the left hand side and also from the right hand side. Okay, so just a heads up, for your case, your limit would exist, and then the limit right here, if I'm not wrong, it equals to 0. Okay, so 0 should be your final answer for your part. Okay, and now let's talk about the last part, unbounded behavior. Okay, so this I'm pretty sure is gonna show up on your exam 1, but I'm not sure if it shows up in your quiz 2, but just be prepared for this one. Okay, so for this one, I can show you guys there's the easy way to do this. You just have to use your calculator to do this. There's a harder way, and then there's like a math way to do this. Okay, so another important way in which a limit can fail to exist is when f of x increases or decreases without a bound, right? As x approaching to c. Okay, so we have like a function in here, like a really like nasty function in here. And again, if you don't trust me, you can plug 0.5 in for each time you see the x in here. Okay, if you do it in your calculator in your free time, you will see that you're gonna have something divided by 0. I did it already, so let me scribble in there. And then this is not like qualify, right? Like we cannot divide anything by 0, right? So that means that we have to do something to simplify the functions. Okay, so if you remember the thing we call grouping method, let me write out the method in here so you guys can look it up. Grouping method, it tells you guys that, well, you can pair these two up and pair these two up, right? And then from the first two term, if you factor out an x squared, you're going to end up with x plus 4. And then for a second term, I mean the second circle, if you factor out a 1 from each of them, x divided by 1 is x, 4 divided by 1 is 4, right? So you're going to have pretty much the same thing. And again, between this group and that group, you have the subgroup of x plus 4, like the same, right? They're sharing the same group. So that's why you can like factor it out. And then whatever is left over from the first like group and from the second group, you put them together. And again, this method is called grouping, okay? And then so this is like what we have for the top part, okay? And then for the bottom part, if you do the x method in here, and if you remember what I told you about a front number, the top number in here should be -8, not -4, and the bottom number in here is 7. So two numbers that multiply each other give you 8, right? There's a lot of options in there, but because I see 7, so I'm gonna go with 8 and 1. And again, I have to pick on which one is negative, right? To make like a positive 7, the one must be negative, okay? So then for the bottom part, I'm gonna get something like x plus 8 and then x minus 1. But then again, I have to watch out for the front number because I have a 2, so I have to divide each of them by 2. In the first pair, I have x plus 4 because 2 goes into 8 4 times, right? But for the second pair, that doesn't work for 2 to go into 1, right? So I'm gonna swing 2 in front, and I'm gonna have 2x minus 1. Okay, so put everything together. I'm gonna get x plus 4, x squared plus 1 divided by x plus 4 again, and then 2x minus 1. And then don't forget the limit in here. X approaching to 0.5 from the right hand side. Okay, excuse my bad writing with the 5. It's a 5. Here, let me make a, like a better 5 for you guys. Okay, that's better. And again, we can cancel these out, right? And now if you plug in 0.5 for each time that you see an x in there, you will end up having, what is it? Still something not like undefined, right? Like if you put like 0.5 on the top part, you're gonna get 1.25. If you put like 0 on the bottom part, you're gonna get a 0. Unfortunately, this is still 0. So does it mean that all the work that we just done is for nothing? Well, no, right? First of all, we simplify the function down, so that's the good stuff. Second of all, it will tell you whether this 0 is actually negative or positive. What do I mean by that? Well, it tells you that you have to count from the right hand side of 0.5, right? That means that you need something that's bigger than 0.5, okay? So now let me just rewrite the function really quick just so everyone is clear with what we have in here. So this is our function from before, okay? And now I want you guys to plug in x equals to, I don't know, something slightly bigger than 0.5. I'm gonna say 0.6. If you don't want to use 0.6, you can plug in 0.51, or I don't know, like 0.501 to be more precise. But I'm gonna go like with 0.6, okay? And make sure you don't go for like 1 or 2, okay? That's like way too far from your original point as of, you know, 0.5. So you have to put something closer to 0.5, okay? So if you plug in 0.6 in here, on the top part, you're gonna get 1.36. On the bottom part, you're gonna get 0.2, which is the sign of positive numbers, right? Because you have like a positive number divided by a positive number. So based on the stuff that we have in here earlier, I'm gonna tell you the final answer in here is positive infinity, period. Okay? So it doesn't mean that we did all these work for nothing. We did all these work to get like a better symbol to plug in, and at the end you have to plug in something close to the C value in there to figure out whether you're gonna have a positive infinity or a negative infinity. Okay? So again, the answer for this one is positive infinity. Let me box it, and here's all the work for it. Let me take these out before you get like confused further, and let me compare it to what we have in the graph in here. Okay, so if you notice, here's the graph for it, right? And here's the dashed line for the value of x equal to 0.5. Okay, so on the right hand side, 0.5, we're talking about this piece right here, right? Because this piece is for the right hand side, and the outer piece that's actually for the left hand side of 0.5. Okay, and in here, because we have a plus in here, so we're not going to even like care about the left hand side. Okay, so on the right hand side, as x approaching to 0.5, so that means that you go from here all the way to like closer and closer to the value. Where are you getting at? You get like, you keep going like higher and higher and higher and higher, right? Toward the positive direction of y. That means you're actually going for the positive infinity direction, okay? And if you want to like challenge yourself, and if you want to change a problem to, I don't know, like limit of the same like function in here, let's copy and paste it out there. But then if you want to calculate the limit of this function when x approaching to 0.5 from the left hand side, well, in that case, we're gonna have to look at this piece right here. Okay, let me put it in pink. This piece in here, because now we're talking about like the left hand side, right? And if you notice, we're gonna come from the left and then closer and closer to your dashed line. But where is the error getting to? It's getting down toward the negative direction on the y-axis, right? So your final answer in here would be negative infinity, okay? That's why these are called like the unbounded behavior, because you either have like positive infinity or negative infinity, okay? But since I told you guys, like I keep telling people that infinity is not a number, right? It's just a concept about big numbers, something like really big. Then in here, you can either give me the answer of like, you know, like positive infinity, or you can tell me that the limit of this function when x approaches to 0.5 on the right hand side, it doesn't exist, because we don't have a value for it. We don't have a number for it. We just have a concept of positive infinity, okay? So that's like either or. Like both of the answer are acceptable for me, because I understand like the concept of infinity. That's like my philosophy of infinity. So in this class, remember, you have two options. This can be the answer, or this can be the answer, okay? And let me put a green star for your part before I forget it. Okay, so conclusion in here. The equal sign, the statement, limit of f of x when x approaching to c on the left hand side equal to L does not mean that the limit exists, okay? So in here, even though you write out that, you know, like, okay, let me put it in pink for, actually let me put it in orange. So limit of that function, I'm too lazy to write like everything down, when x approaching to 0.5 from the right hand side equals to positive infinity. This equal sign, it doesn't mean that the limit exists, right? In here, the limit does not exist, because it's just a concept. It's not like a number. On the contrary, it tells you how the limit fails to exceed by denoting the unbounded behavior of f of x as x approaches to c. So it fails to exceed because it keeps growing and growing and growing. And we're talking about the right hand side in here, right? And then for some tips, personal tips, like I told you before, because this is like positive 0.5 on the right hand side, right? So you can use like 0.51. This number 0.6 if you refer to my like technique, because I want to like, you know, like short numbers. That's better for me. You're welcome to use them, but make sure you have a good calculator, and make sure your calculator shows you how to convert from, you know, like decimal to fraction and so on, so that you're not going to be confused when it gives you a fraction. Okay, so that's it for today, and thank you for your listening. Take care and bye bye.